Okay, so this is a pretty simple but effective use of Bernoulli's principle. We have a sheet of paper, and when we blow over the top of it, it creates a low pressure zone on the top, giving the paper lift. Okay, here's another good application of Bernoulli's principle. As we see here, and a lot of people have seen, you can balance a ping pong ball on a hairdryer without it falling. A lot of people think this is because the air from the hairdryer keeps the ball floating, but when it's analyzed using Bernoulli's principle, we see that the air that's traveling around the ping pong ball has to actually cover a greater distance than the air that just goes past it. So by the time it gets to it has to travel faster to get to the top at the same time. This air that's traveling faster at the top of the ball creates a low pressure zone above the ball and a high pressure zone below it. The high pressure below the ball then forces the ball to stay floating. If you notice, you can turn the hairdryer to one angle or another and see that the ball stays floating even when it's not directly beneath. In this situation, the air flows over the ball, creating a low pressure zone over the ball and a high pressure zone below it. This keeps the ball floating without the air having to be directly underneath the ball. Okay, so what we're doing here is a classic egg into the bottle trick. With this, we have a piece of paper, a lighter, an egg, and a bottle. As you can see, the egg doesn't quite fit into the top of the bottle, but what we're going to do is light the piece of paper on fire, put it in, and it should suck the egg into the bottle. This happens because when the paper is on fire and in the bottle, it causes the molecules to heat up and move faster and faster. When the egg is put on top, some of the molecules escape, but then when the fire goes out, all the particles in the bottle start slowing down a lot, which causes a great drop in pressure. The pressure in the bottle will be then less than the pressure outside, forcing the egg in. Let's take a look. Okay, so here's another example like we did earlier with the ping pong ball, only we're using a leaf blower and a small beach ball. What we do here is the air goes over the ball faster than it does underneath, which creates a low pressure system on top and a high pressure system below, which keeps the ball floating even when it's held at an angle. Now if you notice, even though the ball is not directly over the leaf blower, the low pressure system above it and the high pressure system below keeps the ball floating rather than the air itself from the leaf blower. Physics.
Alright, in this next clip we have a roll of toilet paper, a rod, and a leaf blower. And what we're going to do is blow the leaf blower across the top of the toilet paper. This will result in a higher velocity above the toilet paper and therefore less pressure. And that lower pressure will cause the high pressure below the toilet paper to lift up, causing a lift in the toilet paper.